गुड इवनिंग एंड वेलकम बैक टू द चैनल। स्वागत है बच्चों आपका केमिस्ट्री चैनल केमिस्ट्री गुरु 1993। टिल द लास्ट वीडियो वी हैव completed biomolecule. Now we are going to start D and F block element by Govind sir. Okay, so let's start the chapter D and F block. What is the name of the chapter? D and F block. Come to this. D and F block element. So if we are talking about NEET pattern, so one question from this chapter we are getting, and this chapter plus coordination compound completely in the JEE. If we are talking JEE mains exam, so 3 questions from D and F block plus coordination compound. So one, or you can say maximum two, because in 2021 exam there was 3 questions from D block. Last year it was 1 question, I think, not 100% sure. So basically 1 or 2 question compulsory in the NEET exam. JEE means these 2 chapter combined 3 questions from your JEE NEET exam. Okay, so this is all. So this chapter basically, here you can check on the screen, it is coming unit number 8, the D and F block elements. D block elements and F block element we are going to start. So we'll divide into this chapter into 2 category. Means in the first phase, not case, in the first phase of the chapter we will complete D block, and second phase we will complete F block. So like that we will complete. It's an inorganic chemistry portion, so it will not take more time. So again, here this chapter is by Govind sir. Okay, 10-year plus experience. Now let's start the topic. From here, check it. D block element. So this is the shape of the periodic table actually. You can check. Transition element. D block elements are also called transition element. So this is the shape of the periodic table. Okay. Here S block element. S block element I am coloring with yellow color. Okay. These are the S block element. This element also. Second, P block element. These are the P block element. Different color I am using. You can check it. These are the P block element. So this is for P block. This gap is for P block. And the next one is D block element. This color for D block element, children. You can check it. This is the shape of the periodic table. And here we are having D block element. From the green color below of the periodic table, two series are given, lanthanide and actinide. These are called F block element. So you can check, these are our, this is our periodic table. In that case, we are going to discuss D block element and F block element in this chapter. Check it once again. The name transition is given to the element of D block because of their position between S and P block element. In between S block element and P block element, D block element lies. So these are called transition element. Okay. So check it here. D block element, the D block The D block of the periodic table contains the elements of the group number 3, group number 3 to 12, in which the d orbital are progressively filled in each of the 4 long period. The F block are those in which of the 4f and 5f orbitals are progressively filled. The name transition metal and inner transition metal are used to refer the elements of D block and F block. D block are called transition metal, F block are called inner transition metal. F block, that is inner transition, D block transition. There are mainly three series. Here, check it. There are mainly three series of the transition metals. These are called 3D series, 4D series and 5D series. Okay. Next, what are the points? A transition element is defined as the one which has incompletely filled d orbital in its ground state or in any one of its oxidation state. They are having, what they are having, children? They are having incomplete d orbital. Zinc, cadmium and mercury of the group 12 have fully filled d orbital, check it, d10 configuration in their ground state as well as in their common oxidation state, and hence they are not regarded as transition metal. They are regarded as pseudo transition element or metal also you can say. So zinc, cadmium and mercury, they regarded as pseudo transition elements. This periodic table we discussed already, check it once. Zinc, cadmium and mercury, they are regarded as pseudo transition elements. Transition element because they are having incomplete d orbital, but here d orbital is completely filled, that means d10 configuration is there, so they are referred as pseudo transition elements that we have discussed. Now electronic configuration of d block element. So what is the term general electronic configuration? n-1 d 1 to 10 and ns 1 or 2. So this is the first series, children. This is the first series. Here, this is your first series. Which color? This color. Okay. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Atomic number 21 to 30. 4s subcell, 2 electron, 2 electron, 2 electron, 1 electron. Chromium is the exceptional case, okay? And copper is also exceptional case. That is why here you are having 1 electron. 1 electron in the 4s orbital. Here d orbital, 1 electron, 2 electron, 3, 5, 5, 6, 7, 8, 10. This is completely filled also, and here this is also completely filled. Next, 2d series started with this and end with cadmium. Electronic configuration is given, you can check. What is the electronic configuration of chromium? 24, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. More stable electronic configuration. Copper 29, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. So these are the two exceptional cases in the first series. 3d series, third series, that is called from lanthanum to mercury. Check it once. Here 1, 2, 3, 4. It's called 3d series, 4d series, 5d series, 6d series. Okay, this is the classification, children, for d block element. Here few points. Nickel, palladium and platinum used for hydrogenation as a catalyst. Tungsten, silver and gold, they are coinage metal. That means coins are made from these metals. Zinc, cadmium and mercury, they are called pseudo transition metal. And why transition? Because they are half filled, half filled or empty d orbital, empty d orbital. Check it once. These are the points. In the next case, general property, general properties of the element. Okay, what is written here? General property of transition element. Physical properties, physical properties. The melting and boiling points are, first point, the melting and boiling points are high. They are having high melting point. One graph is given, you can check. Atomic number increases and this is melting point increases. First series, that is 3D series. First series is called 3D series, 3D series, 4D series and 5D series. Okay, so that tungsten is having the higher melting point all over the D block element. And you know, the filament of bulb is made by this tungsten metal. The high melting point of transition metals are attributed to the involvement of greater number of electrons from n-1 d in addition to the ns electrons in the interatomic metallic bonding. Okay, so this is the melting point concept. So here one more thing I want to explain. What are the factors involved in the case of melting point? So what are the factors? That factor we have to discuss actually. Check it once. Solid. What is melting, children? What is melting? Anything, anything is converted into solid state to liquid state. Okay, that is the melting. So what are the terms that affect the melting point? Symmetry of molecule, symmetry of molecule. If molecule is symmetrical, then it is having more melting point, directly proportional. Hydrogen bonding, hydrogen bonding is also directly proportional relation with melting point. Van der Waal force, Van der Waal force, Van der Waals forces also directly proportional to melting point. Metallic bonding, because these are the metals, this is also directly proportional. Surface area, also directly proportional. So tungsten is having the highest melting point element in that case. These are the points I explained. Next point is enthalpy of atomization. What is, guys, enthalpy of atomization, or you can say heat of atomization? What you can say? Heat of atomization, same thing. Heat of atomization, heat or enthalpy of atomization. What is the meaning of this? Enthalpy change when a compound's bonds are broken and the component atom are reduced to individual atom. Definition I am telling you. You can write here: enthalpy change enthalpy change during old bond broken of compound and the component atom and the component atom are reduced to individual individual atom. That is called enthalpy of atomization or heat of atomization. Enthalpy change during old bond broken of compound and the component atom are reduced to the individual atom. Okay, that is the meaning. Okay, you can say it's similar to melting points. This is it's similar to, not exactly equal, but it is similar to melting point. They have high enthalpy of atomization. What they have? D block element. They have high enthalpy of atomization. In general, greater the number of valence electron, greater the number of valence electron, stronger is the resulting bonding. Greater the number of valence electrons, stronger is the resulting bonding. So you can check the graph of this series 1 2 3, and here in 3D series, if we are talking in 3D series, chromium chromium has the highest heat of atomization among the 3D series. Why, children? Because it is written here greater number of valence electron. So in the chromium atom we are having unpaired electron, more unpaired electron. In the chromium atom, more number of unpaired electrons present. What you know? 4s1 3d5, so total unpaired electron will be 6, so it is having high atomization. So directly you can write heat of atomization delta H, and here AT you can write is directly proportional to number of unpaired electron. Number of unpaired electrons. Heat of atomization is directly proportional to number of unpaired electron. Okay, so this is the concept. Oh, variation in atomic and ionic size of transition metal. This is the very important point here. We have to Focus on it. The atomic radius decreases from, first point is I am telling you, atomic radius decreases from left to right across the period. Left to right, if in the period, left to right, here left to right, if you are moving, then atomic radius decreases. The atomic size of the element of the first transition series are smaller than those of the corresponding heavier elements. However, the atomic size of the third transition series is virtually same as those of second transition series due to the lanthanide construction. Here you can check, children. What you can check? You can check 4D, 5D, 3D. Okay. So 4D, this is 4D series and this is 5D series. They are having almost similar, here, this graph. They are having almost similar atomic radius. And this is your third. If you are able to check from scandium, then reduces titanium, vanadium, chromium, manganese, iron, cobalt and nickel. They are having similar, almost similar, not same but similar. And here increases, reversible relation. That means size of zinc is more than copper. According to the concept, it should be less, but here you can see zinc is greater in size as compared to copper. 3D, 4D and 5D almost similar because of lanthanide construction. But in the 3D series, so check it once again. I am explaining. We are having started from scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. These are the elements of 3D series. So from here, from scandium to manganese, actually from scandium to manganese, size decreases, correct. Iron, cobalt and nickel, they are having similar size, not same, they are having similar, almost same you can say. And here zinc is greater than copper. So these are the three category in that case. So what is the reason? What is the reason behind it, children? The reason is two concepts are following here: nuclear charge and screening effect. In the first case, nuclear charge is greater than screening effect, means from scandium to manganese, but here nuclear charge is equal to screening effect, almost equal. And here nuclear charge is less than, nuclear charge is less than screening effect. Two concepts are responsible for this reason. Screening effect increases, size increases. Nuclear charge decreases size. If nuclear charge increases, then size decreases. If screening effect increases, then size increases. Screening effect you know, and nuclear charge also you know. I'm not going to explain. This is for the 3D series. So I hope this is enough for today. Thank you guys. Hope you enjoyed the class. This case. Thank you everyone. Please watch the video and share the video. This is the first lecture of D and F block. Lecture number 1. Lecture number 1 completed for D block and F block. All the best.